and I hear from a friend on a certain social networking site that the Higgs Boson might have been found. Now, for those of you who are going, what? Well, some of you are probably going, too late for all that physics stuff this time of night. Well, yeah, it probably is, but for me, I think of this stuff all the time, so can't help it, sorry. Anyway, the point is, right, the Higgs boson, how can I put this across? It's a bit like, particle physics and the theory of how our world works on the particle level, smaller than atoms. Atoms are particles. Dust particles are particles as well. It's all a matter of context, isn't it? But we're talking of particles in a sense of subatomic particles that are smaller than atoms. And we've got the quarks and the leptons and the bosons indeed. The Higgs boson is one of them. I won't list them all anyway. I won't go into boring detail, because that would be boring detail purely because it'd be missing the point. The point is, the Higgs boson is like, imagine if you had a 1,000-piece jigsaw puzzle and you'd been working on it for months, right? You've been putting all the pieces in, and you've got 999 of the pieces in. I hope there's some physicists listening saying that's not a bad analogy. And they're not criticising it. But anyway, this is my analogy. I'm sticking to it. It's like 999 pieces are all perfectly locked together in place, right? That's like physics theory of particle physicists, right? It's all clicking together, and they're all going, this is perfect. It all works. And then they go to put the 1,000th piece in, right? And the Higgs boson, in this analogy, is represented by that 1,000th piece. And they go to put it in, it doesn't fit. And they're all scratching their heads thinking, oh, that doesn't make any sense. How can it not fit? Everything else works. Everything else fits. Look, it looks complete. It's a complete picture. What on earth's going on? It must fit. And they try to stuff it in, and it's not going in. And so they sort of think, all right, we'll change a few pieces around then. That represents sort of changing the theory, making little tweaks to the theory. Little tweaks, what an insult. Any physicists listening will be thinking, little? We spent 3 years researching that little tweak, I'll have you know. Calm down. Okay. So I apologise. It's just an analogy, okay? So I'm trying my best here. I'm not a particle physicist. I know I've done a PhD and stuff, but not in that area. Anyway, point is, right, so they move a couple of, let's say it's a nice picturesque scene of a mountainscape. So, and we've got perfect blue skies, right? So all the blue pieces look the same. That's again possibly an insult, but in terms of the theory. But I'm not saying they all look the same. They've all got slight variations of colour, okay? But to the human eye, they look the same. There we are. That satisfied them. And so they've moved a few of the blue pieces around and thought, all right, okay, so perfect, right, it's done. Then you go to put the 1,000th piece in again. Doesn't fit. And they're going, oh, come on. This is ridiculous. What's going on? Why can we not get this to fit? That's sort of the story of the Higgs boson. They've been looking for it at different energy levels, and that's the reason they've needed to build bigger and bigger equipment, is because they need more and more energy to find where it is, because it's a very, very high energy particle. So you can only see a high energy particle if you have put enough energy in. All right, I'm using the word see in a metaphorical sense. You wouldn't be able to see the Higgs boson. That would be silly. But it's too small. But anyway, so you need more and more energy to see it. You need to build bigger and bigger things. Of course, the LHC, the Large Hadron Collider, in CERN, in Geneva, which everybody was worried about would create black holes and stuff, which it won't, don't worry. But anyway, that's there. Everybody knows it more because of that story, perhaps, than anything else. But now, I don't know, this is rumour. It's complete rumour. It may be wrong that the Higgs boson has been discovered. I'm sceptical, but it does tie in with an email that I have received via the university, where some people, researchers and people like that, have been invited to go to a press conference in London next Wednesday. Hot off the press, yeah. And I am one of these people who've been invited, not by name. I mean, that would be awesome. If I just graduated and they sent me like a golden letter through the post and said, we'd like you to come, Jamie. We've heard you do a radio show. We need to tell you something. And so, like a big car comes up with blacked out windows or something and sort of stuffs me in it. And Mum and Dad are going, where are you taking him? Oh, it's a secret. I can't tell anyone. But that would be hilarious. But no, I haven't been invited in person. But I am one of the people who it's been put to that I might like to ask if I can go to this press conference. And I'm tempted. I know it's London, it would cost me a lot, but I am tempted. I'd be there, basically, when the news came straight from the horse's mouth, as the metaphor goes. Whether we have to say goodbye, The Power of Goodbye, that song by Madonna, whether we have to say goodbye to physics as we know it, because the Higgs boson still isn't in the right place and still isn't where we're looking for it, or whether we found the Higgs boson, and if we have, well, we haven't quite proved physics. I mean, there's quantum physics, don't get me onto that, but, where the universe is uncertain at a very, very small scale, and so we won't even go there for now, but we may have finished the particle physics bit. At least we might have found all the particles. That's the point. We won't necessarily know exactly how they behave, but we'll have found them all. It's a start.